So this is another property which is dryness fraction. So dryness fraction is important, most important property, okay, in properties of pure substance. So what is dryness fraction? Dryness fraction is denoted by the letter X, small x. Usually they are denoting the dryness fraction by small letter x. Okay, what is the meaning for dryness fraction? It is related with wet steam, the ratio between the mass of actual dry steam and the mass of steam containing it. What is this? Actually, in the next slide I have drawn something. Yes. So this is the saturation curve. We have seen already. In the saturation curve, what is this line? Left to this saturation line is liquid line, right to this saturation line is vapor line, and in the center there will be some liquid plus vapor. Okay, so what is the dryness fraction means? If I supply a heat, then formula, some amount of steam, that is mass of dry steam is there. Okay, it is related with wet steam, the ratio between the mass of actual dry steam and the mass of steam containing it. There is a ratio between mass of dry steam, and also in the denominator I have given ms plus mw. What is happening here? I am just converting the liquid into vapor. Okay, when I converting from liquid to vapor, there will be some amount of water particles present in the conversion. Okay, so in the particular amount of dry steam, how much I have produced some amount of steam. In that steam, how much amount of water particles available. So the ratio between mass of dry steam to the steam containing it is called dryness fraction, right? I think you understood about this. So it is related with the wet steam. The ratio means it is related to wet steam only. Okay, what is the wet steam? In wet steam there will be the presence of water vapor content. Okay, so when it is converting or becoming into steam, okay, it is just beginning to converting into steam. So when it is in the initial stage, there will be some water vapor content. So how much percentage of dry steam is there and how much amount of water vapor particles is there, that both the things are related to dryness fraction. So that what is the quality of the steam, that we can find out by knowing the dryness fraction. If the dryness fraction is less than 1, then that steam is wet steam. If the dryness fraction is equal to 1, then the steam is dry steam. If the dryness fraction is greater than 1, then the steam is superheated steam. Okay, so that you do remember. If x is less than 1, that is wet steam, x equal to 1, dry steam, x greater than 1, superheated steam. Okay, so the dryness fraction is used to find out the quality of steam. So what is the formula? X is equal to ms by ms plus mw. What is ms? Mass of dry steam. What is mw? Mass of water vapor particles in the steam. So this is the meaning for dryness fraction. Okay. Next, total heat or enthalpy of wet steam. So to convert the water into wet steam, how much amount of heat that I required, that is the formula. So that is the definition of this. What is that? Actually, suppose I want to know, okay, I want to convert the water into wet steam only, not dry steam. So this whole portion is wet steam. So this area steam is wet, on this line steam is dry, this right side to this line is superheated steam. So I want to convert the water into wet steam. So at this portion, for example, I am taking, okay, so already I have studied about dryness fraction. So what I will do, from here to here I have to supply a heat. This is heat, I am supplying a heat. What is this? This is HF, right, plus this heat is called, latent heat is called HFG, plus HFG into how much amount of dryness fraction is X. So that the total heat required to convert the water into wet steam is equal to HF plus X into HFG, where you see I am supplying a heat from here to here. See, from here to here is HF, then from here to here HFG is there, but how much proportion of HFG is there? X proportion of HFG is there. So X into HFG. So this is the amount of heat required to convert the water into steam. So what is the formula? H is equal to X into HFG plus HF. This is to convert the water into wet steam. And dry steam formula, this formula is important, please do remember. Okay, H wet is equal to X into HFG plus HF, or HF plus X HFG. Okay, and H dry steam is equal to HFG plus HF. What is HFG? Why HFG plus HF? Because for dry steam I have already told X is equal to 1. So the formula for dry steam is HFG plus HF. Okay, next, total heat or enthalpy for superheated steam. So wet steam, dry steam we have seen. Next we are coming for total heat for superheated steam. Right, now you see the same diagram. Actually I want to find out how much amount of heat or enthalpy required for converting the water into superheated steam. So superheated steam means this is superheated area up to here. What is required? This is you can say this is saturation temperature, and this is superheated temperature of the steam, right? And this is actually I am going to find out the enthalpy for superheated steam, right? Now what is the formula? How can I write? So from here to, I have to go from here to here. So I am just dividing into 3 halves. From here to here I know. So I am going to write the formula for superheated. Okay. So H superheated is equal to, you divide into 3 parts. This is first part, which is HF. Then second one is HFG. Then third one. Actually this is the amount of heat that again I am adding, so that it is a kind of sensible heat. So the sensible heat formula, Q is equal to mCp delta T. So Cp into, that is the specific heat for superheated steam. The temperature difference is T superheated minus T saturation. So this is the formula for H superheated, to find out the amount of heat required to convert the water into superheated steam. You see that H superheated is equal to HF plus HFG into CPS into T superheated minus T saturation. Specific heat of superheated steam, sometime they will ask in the question, which is 2.2 kilojoule per kilogram Kelvin. Okay, that is the meaning. Next one, volume of wet and dry steam. So we have to find out the volume also for wet and dry steam. So Vf is indicating the volume of 1 kg of water, and Vg is indicating the volume of 1 kg of steam. Now what I am going to find out, I have water that I have already heated, it is becoming a steam. When it is becoming a steam, what is happening? Suppose I am taking 1 kg of water. Okay, in 1 kg of water, x kg is converted into steam. X kg of water is converted into steam. Then what is the remaining amount of water? 1 minus x kg is water. In 1 kg, x kg is converted into steam. Then what is the left? 1 minus x is the left. Okay. Now I am going to divide into 2 halves. So to find out the total volume. Okay. So how to find out? So volume of wet and dry steam is equal to x into Vg. What is x into Vg? Vg means the steam. It is converted into steam. Okay. So but what is the quality of steam? So that always you want to multiply with the Reynolds fraction, which is x, plus this is a steam. This particular term is indicating the steam, and this particular term is indicating the water. Okay, so x kg of steam is converted. So to indicate the steam you have to write Vg. To indicate the water you have to write Vf. So this is Vg, this is Vf. Now x Vg plus 1 minus x into Vf, right? So x Vg, then if you simplify this, you multiply Vf in the bracket, then it will become like this. If I again simplify, it will become x into Vg minus Vf plus Vf. Okay, so always Vfg is equal to Vf plus Vg. So sorry, Vg minus Vf, sorry, Vfg is equal to Vg minus Vf. Okay, so that instead of Vg minus Vf I can put Vfg. Okay, so Vg is equal to Vf plus Vfg, so Vfg is equal to Vg minus Vf. Okay, so that the formula for specific volume for wet steam is x Vfg into Vf. Okay, and for dry steam x value is 1, so Vfg plus Vf, I have already told Vfg plus Vf is equal to Vg. So for the dry steam Vg is equal to V dry steam. Specific volume of wet steam formula x into Vfg plus Vf. Specific volume for dry steam formula is Vg, right? And volume of superheated steam. So volume of superheated steam that you can take from the pressure and temperature, pressure volume temperature relation. Okay, P1 V1 by T1 equal to P2 V2 by T2 relation is there. So that there are two terms. One is a saturated steam, that is dry steam, and then one is a superheated steam. So that in the left side I have mentioned the saturated steam and right side is indicating superheated steam. So P into saturation, specific volume of saturation steam by temperature of saturated steam is equal to P into specific heat of superheated steam by temperature of superheated steam. Now I want to know the value of specific heat of superheated steam. So from this pressure is constant, so I will remove the pressure in both the side. So that final formula, that is specific volume for superheated steam is equal to Vs into T superheated by T saturation. So these are the terms are there in the properties of pure substance. So that we have understood about what is a pure substance, okay, how the phase transformation is taking place, and what is meant by sensible heat, what is meant by latent heat, okay, and how to find out the amount of heat required to convert the water or steam from one phase to another phase also we have seen, and we have studied about some of the formulas also in the properties of pure substance. Okay, next topic is Otto, diesel and dual cycles. Okay, so that in this we will study first about what is Otto cycle, what is diesel cycle, what is a dual cycle. Okay, so then we will go for some analysis in the Otto, diesel and dual cycle. Okay, so first we will see about what is this all the cycles. Otto, diesel, dual, all the cycles are gas power cycles. Why it is named as a gas power cycles? Because the working fluid which is entering into the system is in the gaseous form. So that these all the cycles are called as a gas power cycles. If Otto cycle means it is used in petrol engines. In our bikes all engines are working based on Otto cycle principle. Okay, and in automobiles like car and buses and all, the engines are diesel engines. Okay, that is diesel cycle, it is working based on diesel cycle. And dual cycle is the combination of both Otto cycle and diesel cycle. To improve the efficiency of the system, they have also included the dual cycle, so that you have understood the basics of Otto, diesel and dual cycle. So now we will see one by one. Okay, first cycle is Otto cycle. So Otto cycle is also called as constant volume cycle. Otto cycle or constant volume cycle, both are same, and this cycle is used in petrol engines. This cycle is used in petrol engines. Okay, now you see in petrol engine, in engine what will happen in the engine, this is, you consider this is a piston cylinder. Okay, man, in the petrol engine there will be a spark plug. What will happen at the end of the, there are 4 strokes in the engine. Okay, so that we no need to go in deep into the IC engine, you just understand the boundary concept. What is happening in an engine, there is a combustion process, means you are supplying both petrol and air in the form of gas into the engine. Then at the injection, during the injection of petrol and air supply, then at the end there will be some compression stroke. at the end of the compression stroke, what will happen? The spark plug will ignite the fire into the engine, so that the fuel will start, the combustion process will initiate, so that the fuel will burn inside the engine cylinder, so that more amount of pressure and temperature will create inside the cylinder, so that pressure will push the piston from top dead center to bottom dead center. When the piston starts moving, so this is the top dead center of the piston and this is the bottom dead center of the piston. Okay, so at the end of the compression stroke, the ignition is happening. So what will happen? The fuel will burn inside the cylinder, and due to that pressure is creating, that pressure pushes the piston towards this side. Okay, so that now the piston is at TDC at the end of compression stroke. Then what will happen? The piston will start moving from this top dead center to bottom dead center. Okay, now you see one thing, you just listen, you just observe also, and this is the cylinder and this is the piston. You see the position of the piston is not at the extreme end of the cylinder. There will be some gap between the head of the piston and head of the cylinder. So there is some clearance between the piston and the cylinder. That clearance is called as the clearance volume, which is known as VC. So, okay, what is clearance volume? Clearance volume is the volume between the head of the piston and head of the cylinder. That is clearance volume. And you see the piston is traveling from here to here only. Actually that is not bottom dead center. Actually I am just projecting it, and this is bottom dead center. So the piston will move up to here only. So the piston traveling volume is swept volume or Vs. So what is Vc? Vc is the clearance volume. Vs swept volume. Swept volume means what? Piston traveling inside the cylinder. How much volume it is moving to and fro. Okay, so the movement of to and fro is happening in particular volume inside the engine cylinder. That volume is swept volume. Okay, and the total volume, you see, total volume I have noted from here to here. Okay, so you can say Vc and also equal to V2. You can say Vc is equal to V2 because at this point number 2 is available. So from here to here, point number 2 is, you can denote either Vc or V2, and I want to find out the total volume of the cylinder. So V1 is equal to Vc plus Vs. This is the total volume or maximum volume of the engine cylinder. Okay, now you see what is happening, how the Otto cycle is working, how the petrol engine is working. So during suction stroke, what will happen? There is a supply of air and mixing of both air and petrol in petrol engine, that will come and enter into the top portion of the engine cylinder. Then what will happen? After that, the piston will start moving from top dead center to bottom. It will be initially at top dead center only. When the air fuel mixture coming inside, that will push the piston from TDC to PDC. Now, so initially it will move from top dead center to bottom dead center. When it is moving from TDC to PDC, there will be some vacuum inside the engine cylinder. So due to that vacuum, this air and fuel mixture will come inside the engine cylinder, and that will occupy this whole space. Okay, then what will happen? After that, again the piston will move from bottom dead center to top dead center. When it is moving from bottom dead center to top dead center, already this whole volume is occupied by the fuel and air. When it is moving from TDC to PDC, what it is doing? It is just compressing the air fuel mixture. So when it is compressing, what is happening? The volume is decreasing. Anything if you compress, the volume will decrease. Okay, so that this is the process of isentropic compression. Process 1 to 2 is isentropic compression, where we are compressing the air and the fuel mixture. Okay, so the piston is compressing the air fuel mixture isentropically. You have to assume something in the gas power cycle. I am assuming the compression and expansion process as isentropic process. Okay, to simplify some mathematical equations, I have assumed. okay, but in real case it is not like that, but for simplification purpose I have assumed the compression process in an engine cylinder isentropic or reversible adiabatic. Okay, so process 1 to 2 is isentropic compression. Then what will happen? Till now I have not added any heat. There is some heat inside, but in petrol engine that is not that much. Okay, now to start or initiate the combustion process, there is a spark plug, means you are starting the bike. Okay, kickstart means what you are doing, just pushing one button, the engine is starting, you are starting your bike, means that is a spark plug. You are giving some fire to the engine so that the fuel starts burning. Okay, that is meant by the combustion process will take place. But during the combustion process, what will happen? Okay, the piston will not move, the piston will be at that position only. Piston will not move for small period of time, for small fraction of second. The piston will be at this particular stage only. It will not start moving from this point to this point. Some particular fraction of second, it will be at constant position only. But you are adding a heat to the engine cylinder, so that this process, you see, process 2 to 3 is constant volume heat addition, means I am adding the heat to the system, but I am not, because of that there is no changes in the volume. Volume remains constant, but heat is adding to the system, that is QS. I am adding the heat at constant volume. That's why this process is called this cycle is also called as constant volume cycle. Now after adding the heat to the engine cylinder, what will happen? The fuel and air will start burning, then combustion will take place. Due to that, some amount of pressure will be creating at this section. That pressure will push the piston, then the piston will expand. Okay, then this is an expansion process. During expansion process, what will happen? If you expand something, the volume will increase. So you see the volume from 3 to 4, it is an expansion process, isentropic expansion process. So in 3 to 4 is isentropic expansion process, the gas is getting expanding. Okay, that is power stroke. Next 4 to 1. 4 to 1 also, after reaching the piston, there are two ports. This is inlet port and this is exhaust port of the, this is inlet port or inlet valve, and this is the exhaust valve of the petrol engine. During suction stroke, air and fuel mixture will get entered through this inlet valve into the engine cylinder. Then after completion of the power stroke, the piston will be at the bottom dead center. Then again the piston will start moving from bottom dead center to top dead center. That time what will happen? Before it starts moving, actually exhaust valve is to just send out the burnt gases from the cylinder to the ambient or environment. Okay, so when the exhaust valve will open, means before the piston starts moving from the bottom dead center towards the top dead center, before one fraction of second, before it starts moving, maybe the piston will be at rest condition for fraction of second, that time itself this valve will open. So piston is not moving. If the piston is not moving, then volume is not changing. So that particular point, the heat is rejecting from the system. So heat rejection is also taking place at constant volume. So that is heat rejection, constant volume heat rejection. Okay, so there are four processes like that. In TS diagram also I will mention. This is a PV diagram of Otto cycle. This is a TS diagram of Otto cycle. Okay, and what is happening from 1 to 2? Isentropic process, as we have already studied in the entropy concept. Okay, where there is no changes in the heat. Then what is that? S1 is equal to S2. When it will become? What is ds? ds is equal to dq by t. Okay, when there is no changes in the heat, when q is equal to 0, ds is equal to 0. ds means S2 minus S1 is equal to 0. So S2 is equal to S1. When there is no changes in the heat, the entropy will be constant. So when there is no changes in the heat, mean the type of process is isentropic or reversible adiabatic process. So I have assumed process 1 to 2 is the isentropic compression process. So process 1 to 2 is isentropic process, so that entropy is constant, which is S1 is equal to S2. And from point number 2 to 3, that this process is constant pressure heat addition process. So when you add the heat, what is happening? You see the temperature, here it is T2. but you see the temperature at 3, it is T3. So that temperature is increased from T2 to T3 when you add the heat to the system. Then 3 to 4 is the constant volume, 3 to 4 is the expansion process. So expansion also isentropic expansion. So this is also S3 is equal to S4. This is isentropic expansion, right? So 3 to 4 isentropic expansion, then 4 to 1 is the constant volume heat rejection. You see the temperature of point number 4 and point number 1. T4 is here, this is T4 and T1 is here only. See the temperature variation. If I remove the heat or reject the heat from the system, the temperature is decreasing from T4 to T1. So this is the PV diagram and this is the TS diagram for the Otto cycle, and some of the other terms also there to understand the Otto cycle. First one is the compression ratio. Compression ratio, it is the ratio between the maximum volume to the minimum volume. Okay, in this cycle, what is the maximum volume? Maximum volume is V1, and what is the minimum volume? Minimum volume is Vc or V2. So the compression ratio, it is the ratio of maximum volume to the minimum value. So the maximum volume you can say Vc plus Vs, and divided by the minimum volume is Vc. You can write the formulas in both the form. Either you can write Vc plus Vs, Vc plus Vs by Vc, or you can write V1 by V2. Okay, that is the formula for compression ratio, is denoted by the small letter R. Okay, next expansion ratio. Expansion ratio is the ratio between the expansion points. Okay, so that is V4 to V3, where the expansion is taking place.